Hello class, so today we're going to be going over the Pythagorean identities. So let's just recall first what they are. So if we have a right triangle, that looks like this, we have A, B, C. Then a squared plus b squared equals c squared. All right. So given that, then it should make sense then that if we have something squared plus something squared equals something else squared, we get something like this, right? So notice it says if we have a right triangle. So keep that in mind. That'll be very, very important later on. Actually, by that I mean literally the next section that I'm going to go over. All right. So you actually don't have to memorize these. The only one I ever memorize is this one, and I derive the other ones really quickly with that. So the question is, where does that one even come from then? So here we have a right triangle. So let's do the Pythagorean theorem on it. So we have a relationship here. Something squared plus something squared. So the sum of the square of the legs equals the square of the hypotenuse. Also, quick little side note, since this is the unit circle, we can conclude that sine of theta is the y value and cosine of theta is the x value. Alright, so how are we going to use this? Well, we can do that. Have the sine be that, have the cosine be that. So we get cosine of theta squared plus sine of theta squared equals 1. Well, we can also just switch those. So we have sine squared theta plus cosine squared theta equals 1. Notice that I wrote the square between sine and theta. The reason is because if you wrote sine of theta squared like this, that could either mean sine of the angle squared or sine of theta whole thing squared. Which one is it? No one knows. So basically, no matter what angle we have, we don't care what this angle is. No one knows, no one cares. The point is just that with any angle in the unit circle, if you do sine squared of it and a cosine squared of it, add it together, you get 1. Okay, so let's use this then to get the others. So we're going to apply an interesting trick. Remember, equations are nice because as long as you do something to one side and do it to the other side, you can do whatever you want to them. Just some things are more useful than others. So first thing is we're going to just divide cosine squared from both sides. So we get sine squared theta over cosine squared theta plus cosine squared theta over cosine squared theta equals 1 over cosine squared theta, right? So cosine squared divides with cosine squared. In other words, anything divides itself to get 1. Sine over cosine is tangent. So sine squared over cosine squared is naturally tangent squared. Similarly here, we get secant squared. Alright, so now with that, we have already proven or derived the second one. Let's do the same thing to the next one. Sine squared over sine squared. And then cosine squared over sine squared equals 1 over sine squared. Similarly, sine squared will divide out. You get 1 cosine squared over sine squared is cotangent squared, and then we get cosecant squared, and we have proven the second one. So notice that if you just know sine squared plus cosine squared equals 1, you can get the others really quickly. Like, I actually just derive these on my own really fast because I kind of forget which thing goes in what position and where goes what. So I just go like, okay, divide by cosine squared. Okay, tangent on one side, secant on the other side, 1 in the middle. Similar with the other one. So let's work with these. How to work with them, same guidelines as the last time. You can pause the video and copy it down if you want. I literally copy and pasted this. Alright, moving on. Let's just try them now. So, here you have cosine minus cosine times sine squared equals cosine cubed. Remember, you want to look at the blue side only. Start there. Left-hand side equals the right-hand side. You want to show that that's going to happen. This is the last time I'm going to box them because I don't want you to get into the habit of boxing them necessarily, because that's not always useful. Like, there's nothing magical about it. Here it's just color coding for teaching's sake. Anyway, let's look at what we can do here. Cosine, cosine. We can factor that out. So I'm just going to do that real fast. Cosine of theta times, so that's going to be a 1 minus sine squared of theta equals, so 1 minus sine squared, remember, we have sine squared plus cosine squared equals 1. If you were to subtract sine squared from both sides, you'll get this. And then you get that. So that means we get cosine squared here. So we have cosine times cosine squared theta. That's the same thing then as cosine cubed theta. So we have verified that the blue leads to the yellow. Alright, next one is going to be a little bit more tricky, so I'm not going to expect you to just pause the video for this one necessarily, because this may actually be the first time a lot of you have seen this structure. We want to somehow get 1 plus sine. So let's just multiply top and bottom by 1 plus sine. This is actually a special thing that we call multiplying by the conjugate. So you have a difference up here, so just multiply by the sum, because remember, if you have a sum times a difference, whoops, that was supposed to be a minus, then you get the first thing squared minus the second thing squared. So we're going to use that structure up here. 1 squared is 1, sine squared is sine squared, divided by cosine x times 1 plus sine of x. Alright. So 1 minus sine squared, there's that thing again. By now we know that that's cosine squared of x divided by cosine of x times 1 plus sine of x. So one of those can divide out in the numerator and the denominator. So what we have left then is cosine of x over 1 plus sine of x. And that's actually exactly what we want. Alright, next one. This is going to be a fun one. So this one isn't actually as bad as it looks. It's just you gotta multiply things out correctly. If you don't, then it'll be hard. Actually impossible. Okay, so I'm going to write the first one over here and the second one over here. So it's going to be first thing squared plus 2 times their product plus second thing squared. It is not the first thing squared plus the second thing squared only. Think about the puppies. All right. And then the second one over here is going to be first term squared minus 2 times their product plus second term squared. And I notice I wrote it in this way. This is just an easier way to organize it, because then you can see all the like terms. So those can subtract out. And I notice that we have that, which is just sine squared plus cosine squared, right? Here we also have a sine squared plus cosine squared. So this equals 1. This equals 1. and they're being added, correct? So 1 plus 1 equals 2. And that's exactly what we want. So this one was a bit tricky. This one was also a bit tricky, but as you just see this happen more and more and just keep practicing them, you'll be able to get them a lot more easily. Alright, and the next one, we're going to go over something called sum and difference identities.